Okay, so I like to, instead of just telling you here's what all the trig derivatives are, memorize them, I like to show you why they end up being what they are. So just humor me for like a minute. Do you remember when we did the graphing derivatives and I gave you those envelopes and you matched them up and stuff like that? And it was positive is increasing, negative, decreasing. We're going to do that again. So here's where we would have critical points. This is sine of x. We would have critical points at pi over 2 and 3 pi over 2. So when you go to graph the derivative, you can go ahead and put your critical points there, pi over 2 and 3 pi over 2. The reason those are zeros is because that's where there's a zero slope. And see how this part's increasing? We want to be above sea level, and then decreasing is below, and then above. So we want to start out above, and then below, and then above. And so what did we end up with? Like, what is this the graph of? Cosine. So derivative of sine is cosine. And we're going to put that all together on our little organizer in just a second. But that's just an example showing you like why that is what it is. Here's cosine. So if we draw in where our zero slopes are, that's where our critical points are. So we're going to put those on our derivative graph. We've got them at 0 and pi and 2 pi. And so here we are decreasing. We want to be below sea level and then above. So we're going to be below and then above. So it will look something like this, below and then above. So that's not exactly sine of x. It does start at the origin, but it's not sine. It's actually negative sine because it got reciprocated, or not reciprocated. It got flipped over. It's a reflection over the x-axis. And then here's your graph of tangent. Do you remember these from pre-calc? Tangent and cotangent with these wiggly ones. Do you remember what secant and cosecant look like? Because it's going to come up in just a second. Do you remember those U shapes? The ones facing upwards that you took pre-calculus, yes. Oh, that was your missing year. Okay. All right, so here's your graph of tangent. We have asymptotes right here at pi over 2. See, I have this one scaled by pi over 4. If you look, I know it's like really tiny. But if we have asymptotes there, we're going to have them in the derivative as well. So you can go ahead and copy those over. I have trouble seeing it. And then I guess just kind of watch me point to this. You're not going to actually end up with a fully zero slope here. Do you see if I draw in a tangent line in this place in the middle, how it's still kind of positive? It's never like quite horizontal. So, and then the rest of this is increasing all the time. So if this is increasing all the time, we're always going to stay above sea level. So it's going to like come down to like almost zero, but not quite. So, and we're going to stay above the x-axis. So it's going to do something like that. And I'll keep going. You'll have all these U shapes. So that is the graph of secant. But to make it positive all the time, it's actually secant. Like, how do you turn something positive? Squared. Good. So it's actually going to be secant squared. So that's why that is. Derivative of tangent is secant squared. And again, we're going to put that on our bubble sheet in just a second. And those are the only ones I really do by graphing. After that, I usually just use a quotient rule. I'm a little hesitant to ask because you said pre-calc is the class that kind of was online for you guys. Do you remember how to rewrite cosecant though? Like what that would be 1 over what? So, oh, good. Okay, perfect. 1 over sine. And we're going to do a quotient rule for that. So if you remember where quotient rule starts, you will probably get the rest of it because it's a lot like product rule, just with subtract instead of add. Where does it start? Because if you get that at the bottom, you should be okay if you remember where it starts. So denominator times derivative of the numerator. Derivative of 1, though, be 0. Derivative of any number is just going to be 0. Minus the numerator times derivative of the denominator. We just said the derivative of sine is cosine. Good. And then it's over the denominator squared. So simplifying that down, this part's gone because that's just 0. So you would have negative cosine of x over, now sine squared, I'm just going to write it as sine times sine. because that's what squared means. It means you have two of them. And I'm also going to put a 1 in front of that cosine. I'm going to kind of like break it into two parts. If we do negative 1 over sine, that would be negative what? We just said 1 over sine was equal to what? 1 over sine is cosecant. And then do you remember what cosine over sine is? If not, I will tell you, but I'm just throwing the question out there. Oh, good. It is cotangent. So derivative of cosecant is negative cosecant cotangent. And that's why that works out. You can always do a quotient. But yes, okay, thanks for humoring me. I like to explain where they come from, but yeah, at the end of the day, you are gonna memorize them, make some flashcards, okay? So let's pull this out and we're gonna use the large bubble here because we have to fit all of these trig derivatives in. So there's the 6 trig functions, and then there's 3 of the arc ones, the inverse trig functions that you have to know, so write small, okay? D dx means take a derivative. Derivative of sine is cosine. Right? Derivative of cosine, we just saw by graphing, is negative sine. And derivative of tangent, remember those U shapes, but they were all positive. So derivative of tangent is secant squared. Perfect. I don't know, would graphing, does that help you remember at all? I mean, better than flat out memorizing. I realize it's a lot. Okay. All right, so derivative of cosecant is negative cosecant cotangent. We did a quotient rule for that one. And then derivative of secant is secant tangent. And then derivative of cotangent is negative cosecant squared. Yeah, squared, sorry. So rather than trying to, this is my pep talk and my advice, this is how I remember them. Rather than trying to memorize that as 6 totally independent pieces of information, kind of group them together. Do you see how sine and cosine are buddies? I call them buddies because we don't have a better, like they're not reciprocals. Do you know what I mean? Like I call them buddies because I don't have a better word than that. Do you see how sine and cosine go together though? Do you see how tangent and secant go together? They're buddies. Tangent is secant squared, secant is secant tangent. Okay. And then do you see how cosecant and cotangent go together? And they go together in the same manner. Tangent is secant squared. Cotangent is negative cosecant squared. Secant is secant. Like, do you see what I'm saying? Like, it's in the same manner. The cos are the negatives. All the co ones get a negative. So if it's a co, it gets a negative. Buckle up, because I'm going to give you the arc ones now. You ready? You only have to know 3 of those, not all 6. That's okay. I'm going to go over it right now. Derivative of arc sine is 1 over square root 1 minus x squared. And here's what I always say about this one. They may throw one of these on the AP exam on the multiple choice. Like it might show up. You know, they could be super evil and put it on the free response. I have never seen that come up, but you know, well, not true. I saw an arc tangent. Actually, that's not true. I saw an arc tangent on the free response part. It can show up. But what I always tell everybody, this class involves too much memorization. You don't even know where we're headed after this. The amount that you're gonna have to memorize for this class is astronomical. And you're gonna have to decide what you let go because it's gonna be too much. Okay, so you're gonna have to make a decision what you wanna memorize here. All right, and then derivative of arc tangent is 1 over x squared plus 1, or 1 over 1 plus x squared. Doesn't really matter what order you write that in. And, you know, up until a few years ago, those were the only 2 arc ones we were told you had to know. But then they started throwing arc cosine in there. But it's not too bad if you know arc sine. Arc cosine is the exact same thing, just with a negative in it. So notice I just copied over arc sine. I just threw a negative in front of it. So I've started going over that one in the notes now because a couple of years ago, they kind of added that one in. So I'm like, all right, If it's potentially on the AP exam, I'm gonna cover it. But make yourself some flashcards because you do just have to know them. But the co's are negative, and just remember who's buddies with who, okay? Let's practice. Oh yeah, what is that acronym? Morass teaches some kind of acronym that goes, but I don't know what it is. I don't really use it. Well, what's the word? Isn't there a word that goes? Oh, that's not a word. It's just that. Okay. Cool. Whatever works for you. All right, here's the deal. Power rule, product rule, quotient rule, and chain rule didn't go away. They all still exist. We're just putting trig into them. So what other rule do you need? I realize there's sign here, but what other rule is going on? Good. Two things are being multiplied. The x squared is the first thing. Sine of x is the second thing. These are going to get very long horizontally. Okay, so start over like on the edge of the paper so that you have enough room. Okay, so product rule, it would be the first thing, so x squared, derivative of the second, so derivative of sine, cosine, good, plus the second thing times derivative of the first, which would be 2x. You could factor that. The only thing they share in common, though, is just an x, so I don't know how worth it would be. What rule is going on here? It's kind of chain rule. The common mistake I get is product rule, but it's not a cosecant of x times all of this. It's cosecant of that. It's a very subtle difference. Let me show you. If it was cosecant of x and then times all of that, do you see the difference? It is very subtle. This would be a product rule, but that's not what we're doing. It's chain rule. It's cosecant of that stuff. Again, start kind of over here because it's going to get long horizontally. Derivative of cosecant. First of all, it's a co, so it's going to have to be negative. And if you don't have it memorized yet, that's fine. Look back at your bubble sheet. What's your derivative of cosecant? Good. Negative cosecant, cotangent of all of that stuff, the guts of the problem. So negative cosecant of all of that, cotangent of all of that. And then we're going to chain on the derivative of the stuff in the parentheses, like the guts of it, which I'm kind of running into this hole punched in the paper, but we would chain on what is the derivative of that stuff in the parentheses, 4x. Now, if you saw this as a multiple choice question, they would put that 4x out front as the coefficient, so you would see negative 4x times all of this. I don't care. For me, please don't rewrite it. It's honestly easier for me to grade if you just leave it like that. All right, what rule do we need for this one? Chain rule. There are 3 links in the chain. The first one is the fourth power. Inside of that is cosine, and then inside of that is 9x. Do you ever see those cartoons when you're a kid where like the medium fish eats the smaller fish and then the big fish comes and eats it? That's what it's like. There's 3 of them, okay? So first, the power rule. We're going to bring the 4 down, drop it to a 3. Everything else stays the same. So power rule, we brought the 4 down, dropped it to a 3. Everything else stays the same. Then we're going to chain on the derivative of cosine. And I usually get asked, well, what about the fourth? We're done with that. That fourth power is done. We took care of it. What's your derivative of cosine? Good. So negative sine of 9x, it's still the insides. And then the last link in the chain is the derivative of the 9x, which is just 9. I don't want you to rewrite it, but again, just for the sake of being thorough, they would put this negative out front, and they would also multiply the 9 and the 4. So in multiple choice land, it would be negative 36 cosine sine blah, blah, blah. Okay. This one is 2 separate terms. So we're going to do this one minus and then do this one separately. It's 2 separate things. That's just secant. What's the derivative of secant? Look back if you don't remember because we just went over it. Good. Remember, secant and tangent are buddies. And there was no chain rule. It was just x. That's it. Minus, now this one is a chain rule. We're going to do the second power first, then derivative of tangent. So bring the 2 down, it's going to drop to a 1. I tend to write that 1 because if it goes away, it confuses everybody. They're like, wait, what happened to it? It's still there. It's just a 1. If you don't want to write it, you don't want to. So we did the power. We brought the 2 down, dropped it to a 1, and then we're going to chain on the derivative of tangents, which is secant squared. And again, you could factor that. I'm not going to make you do that. They share a secant and a tangent in common. Do you see that there? You could factor that out, put it out front, and then put what's left. You guys are kind of, do we need to do that? Kind of just staring at me. You could factor that if I made you? Okay. What rule is this one? Quotient, all right? Where does it start? If you know where it starts, you should be okay. The bottom, all right, cotangent times derivative of the numerator, which is just be 4, minus the numerator times derivative of the denominator. All right, it's cotangent, so it's going to be negative. The co's get a negative. And then think about who cotangent's buddy is. Cosecant squared, perfect. Is it coming back to you a little bit from last year? Like, good. All right, and then it's all over the denominator squared. This one's going to be a lot of fun. What rule do we need? Actually, there's a couple different rules we need with this one. We need chain and product rule. The first thing is the sign of blah, blah, blah. The second thing is secant of x. I might have to go down to the next line for this one. This one's going to be kind of long. All right, so product rule. We want the first thing, so sine of 5x squared. First thing times derivative of the second. Derivative of secant. Okay, there won't be a negative. Who's secant's buddy? Think about that. And then what's your derivative of secant? Good, perfect. Secant tangent. So that's first times derivative of the second, plus, I'm going to go down to the next line. The second thing times derivative of the first. Now, when you do the derivative of this, that's a chain rule. Sine got hungry and ate 5x squared. All right, so do the outside first. Derivative of sine. Cosine. So cosine 5x squared. Chain on the derivative of 5x squared, which is 10x. And then I threw a couple of the arc ones in there just for us to practice. They also involve a chain rule because it's not just x. See how I threw a 7x and a 3x squared in there? All right, so for arc tangent, it was 1 over, now the rule says x squared plus 1, but it's whatever's there squared plus 1. So if you square 7x, what are you going to get? Good, 49x squared. Not done, because there's a chain rule. You have to chain on the derivative of 7x, which is 7. Now you can put times 7 off to the side if you want, but I usually just go ahead and put it in the numerator. But you'd better believe in a multiple choice scenario, they would put 1 over 49x squared plus 1 as one of the choices. So you just got to be extra careful. All right, and then this one, arc sine, it's 1 over, put a square root. Now the rule says 1 minus x squared, but it's 1 minus whatever's there squared. So if you square this stuff, you will get 9x to the 4th. Perfect. We're not done because you have to chain on the derivative of the stuff I circled. And again, I usually just go and put it in the numerator. That would be 6x. Those aren't bad though, because you kind of just memorize it and write the answer. Versus this, which is a whole lot of work. All right, and then I have some that involve a little bit more. Write the equation. What 2 things do you need to write an equation? A slope and a point, perfect. I always write it out blank so I can fill it in. You're gonna need to keep calm and know the unit circled here. We wanna write this at pi over 3. How do you get the other part of the point? What are you gonna do with pi over 3? Plug it in, okay? Do that before you do the derivative because you don't wanna mix these up. All right, here we go. Pi over 3 times 3. That's kind of convenient because that would just be pi Draw a circle up here. Where's pi? Up, down, left, or right? Left. And what was it, cosine? Cosine is which part of that? So the -1 to the 5th. -1 to the 5th is still just -1. So it'll just be -1. All right, slope comes from what? Derivative. So now we need to do the derivative. There are 3 links in the chain. What's the first one we're going to do? The exponent. Good. Bring the 5 down, drop it to a 4, leave everything else the same. Chain on. Now what's the next link in the chain? Good. Derivative of cosine, negative sign, and then leave the insides the same. Perfect. And then chain on derivative of 3x, which is 3. And what are we going to plug into that? Yep, that's your point of tangency. Now, before you get nervous, it's actually not going to be so bad. Look right here. If you plug in pi over 3, the 3's cancel. It would just be pi. I have pi still written up here. What's sine of pi? 0. So the whole thing is 0. It's a horizontal tangent line. That happens a lot with sine and cosine. Do you get what I'm saying? Because it's all 1s and 0s up here. So you end up with 0 a lot, which is nice, right? So let's assemble the equation. It would be y minus 1. Or actually, yeah, plus 1 equals, no, humor me, let's just fill the whole thing in. It would be your slope and then x minus pi over 3. I realized that would all just be 0. And then you would subtract over the 1 and get y equals -1. Like, I get that. I like to write the whole thing so that you don't forget how to write an equation. All right, and then last one here. At what value of x does this function have a horizontal tangent line? That means slope is 0. You want to get your derivative, set it equal to 0. The critical point. Where, or I guess critical points, there might be more than one. I forget what the answer is here, but derivative equals 0 is what we're going to do. So what is this derivative? Derivative of just plain x. 1, perfect. And then derivative of sine is cosine. And we're going to set it equal to 0. Solving trig equations is another thing from pre-calc. So I don't know, this might be a little dicey. What would you do to start solving that? I'm just going to throw the questions out there and I'll see what I get from you. Yeah, subtract 1. So what you want to do is find a place on your unit circle where cosine is -1, where the x value is -1. I already have it written up there, but do you see how the x value right here is -1? Yeah. So your answer is what? Where is that on the unit circle? Pi. And 3 pi and 5 pi and 7 pi and 9 pi. Do you get what I'm saying? Like, because you can go around, or -pi, -3 pi, negative, like, et cetera, et cetera. Okay, go ahead and flip over. We're going to do the exponential and logarithmic ones. I know, I like these ones, especially e to the x. So if you start drawing in tangent lines, look, they have positive slopes, but they're not very steep, and then they get steeper and steeper and steeper. So when you draw the derivative, it starts out real small and then goes up and up and up. You'd think after messing that up enough times, I would get with it, but I like never do because I can see it, so I always forget. So e is its own derivative, which is great. So ln of x, if you start drawing in tangent lines, do you see how they're really steep? Yeah, okay, and then they get lower and lower and lower, but never quite get to 0. So this one goes like this. And that's a little bit trickier to see from a graphic perspective. But what is that the graph of? Like, so part of it's missing, but do you remember what this one is? Like if I drew in the rest of it, would you know? It's rational, it's 1 over x. Why isn't this part there though? Is there any graph over here? No, so there can't be anything over, like, if it's not there on the original function, it's not going to be there on the, but it is rational. All right, so go to your little bubble sheet and we'll fill in, use whichever one of these you want. We only have one more to do next time. So this is exponential and logarithmic. Derivative of e to the x is e to the x, everybody's favorite. Derivative of ln of x is rational, 1 over x. Now the rule says 1 over x, but remember, if there's a chain rule, it's 1 over whatever's there, and then you chain on the derivative of whatever's there. Now again, just like with the arc trig functions, to be super thorough, because it's fair game for the AP exam, if they make the base something that's not e, for example, 2 to the x or 7 to the x, you know what I'm saying? Like this is, you know, e is a number, right? Do you remember about how much e is? But yeah, like as long as you know it's 2 point something, I'm happy, okay? So I'm gonna put these ones on here, again, just for the sake of being thorough. If they change it, instead of e to the x, I just put a to the x, like if it's some other number, it's still itself, and you just multiply on ln of a. So like whatever that number was. So it would be like 2 to the x times ln of 2. Like it's just that one extra step that you have to remember. And this one's the same thing. If they give you a logarithm that's not ln, like log, I'm writing log base a of x. Do you remember the ones written like that? We don't do too much with those in AP Calc. It's usually ln. But say they give you a log base 3 or a log base 4 or something like that. It's still 1 over x. So like it's the same thing. You multiply on 1 over ln of a. So again, it's just like one more thing to remember, but I showed it to you because they could throw one on the exam. That would probably be like, you know, multiple choice kind of thing. All right, we're just gonna try a bunch of these. Yay. And some of these first ones should go pretty quick. All right, so don't overthink the e to the x ones. Derivative of 3e to the x. 3e to the x, good. No overthinking. Just be happy that it's easy. Now, what rule do we need for that? Product rule, all right? It is going to be the first thing, x squared, derivative of the second, which is just e to the x, plus the second thing, which is e to the x, times derivative of the first, which would be 2x. I won't make you factor that right now, but do you see what they have? What do they have in common? Like, what do both of these terms have in common that you could take out? GCF. E to the x and an x. You could factor that out. Okay. This one's chain rule. It's going to be e to the stuff. What is it? 4x squared. Just like what I get all the time when I teach Calc AB and they see this for the first time, I'm like, it looks like you just rewrote the problem. And I'm like, yep, sure did. That's all it is. And then you chain on the derivative of 4x squared, which would be 8x. All right, this one is quotient rule. So it is the denominator times derivative of the numerator, which would be what? What's the derivative of the top? 2, perfect. Minus the numerator times derivative of the denominator. Okay, it will be itself times what? 5, good. Derivative of 5x would just be 5. Over the denominator squared. Watch me write this. Instead of writing e to the 5x squared, I'm actually just going to write it twice. Because since e is its own derivative, you ended up writing the same thing a lot of times, and you actually can cancel it out. Do you remember how I said don't cancel these? You can in this case because there is one in all 3 terms. Do you see that there? Like if it's in all of them, then you can cancel it out. So you could cancel out of e to the 5x because it was everywhere. Because you could factor it out and then cancel it. And then here's an example of one that's not e, it's 7 instead. So it would still be itself 7 to the power x squared. And there would still be a chain rule. You would chain on the derivative of x squared, which is 2x. It's just if it's not e, there's that one extra step. You would chain on ln of 7. So it's like you just one more thing to remember to put on there. It doesn't make it harder. You just slap that on at the end. All right, those are all the e ones. Now we'll do ln. Derivative of ln is rational. So it's 1 over x. This one's just going to be 4 over x because there's a 4 there. Like I literally just stuck a 4 in the problem. That's all that is. Right, this one would be a product rule. 2x cubed is the first thing. Ln of x is the second thing. Again, start over on the edge of the paper because they get long like horizontally. So it is the first thing, 2x cubed. Derivative of the second, which would be 1 over x, plus the second thing times derivative of the first, which would be, what is that, 6x squared. Won't make you write this, we'll just do it verbally. Do you see how one of the x's would cancel in this first term? What would you actually have here? 2x squared, good. This is not a product rule. It is what rule? Chain rule. And again, it's a very subtle difference. If it was ln of x times all that stuff, but it's not. It's like ln got hungry and ate 5x squared minus 3x plus 8. So derivative of ln is rational. The rule says 1 over x, but it's 1 over like whatever have you. And then you chain on the derivative of that stuff. Now you can put times and write it off to the side. I usually just put it in the numerator though. That would be 10x minus 3. Oftentimes on the AP exam, they'll make those factor and you have to factor and then cancel stuff out. I know, algebra. It is the algebra that gets everybody every time. It's not the calculus. The calculus is the easy part. It's the algebra that's hard. All right, here's a quotient rule. Denominator times derivative of the numerator. All right, that's a chain rule. It would be 1 over what's there. So 1 over 2x times the derivative of 2x, which would just be 2. That's always kind of weird when that happens because what's going to happen to the 2's? Yeah, the 2's are going to cancel. So denominator, derivative of the numerator, minus numerator times derivative of the denominator. Oh, I threw trig back in there. Derivative of sine, cosine, over denominator squared. And then I threw one in here that's not ln. Again, just to show you what that would look like. It's log base 3 instead of ln. It's still going to be 1 over whatever's there. Like, it's not different. There's just one thing that you tack on at the end. So 1 over whatever's there times the derivative of that stuff, which would be what? You do the derivative of the insides. 20x. And then you just multiply on 1 over ln of 3, whatever the base was. And yeah, you would get some cancellation, whatever. Canceling. 20 divided by 10 would be 2, so the x's would cancel. Following me there? Okay. In multiple choice, they would simplify it down. So I want you to be able to simplify things. But I'm also not trying to torture you. It's a fine line to walk. All right, how many links are in the chain here? 3. Which one goes first? Exponent. Bring the exponent down. It's going to drop to a 2. Leave everything else the same. Chain on derivative of cotangent. Okay, first of all, it's a co, so there's going to be a negative. And then think about cotangent's buddy. Who is cotangent buddies with? So it's negative cosecant. Wait, good. Oh, but not of x. What was it? E to the x. Leave the insides alone. And then you chain on derivative of e to the x. Just e to the x. This one also has 3 links in the chain. Secant got hungry and ate ln, which ate 4x. All right, so start with the outside. This one's also going to be really long horizontally, so maybe just like start over here. Derivative of secant. Who is secant's buddy? So it is secant tangent, but it's secant of all that stuff, tangent of all that stuff. Like all this inside stuff comes along. So secant of ln of 4x, lots of parentheses, tangent of ln of 4x. So that takes care of secant. Now we're on ln. Derivative of ln is rational, so it'll be 1 over 4x. And then lastly, you chain on the derivative of 4x, which would be 4. But this happens every time. It's weird because it's rational. What's going to happen to the 4s? Yeah, they cancel. Every year when I do this problem, whether I'm teaching A, B, or B, C, it doesn't matter. Everyone just stares at me like, what on earth are you talking about? You have to remember some properties from pre-calculus to do this. You want to do this with logarithm rules, like rewrite this equation first to break it into manageable pieces, because otherwise, what would this be? A chain rule with a quotient rule and a product rule and another chain rule inside of it? Like, that would be nuts. Do you get what I'm saying? Okay. Do you remember that rule in pre-cal where you're allowed to take the exponent and write it out front? Okay, you might be the first person that's ever said yes to me. Do you remember that rule in pre-cal where you take the exponent and write it in front? Usually everyone's like, no. Okay, so here's how this one would look. ln of x squared, you would take the 2 out front and just write it as 2 ln of x. You take the power and write it as the coefficient. Let's try that again. Plus, now we're going to do this part. Do you remember what the power is for a square root? 1/2, good. So we're going to bring the 1/2 down, put it out front, and then ln of the x minus 1. So you're just taking the exponents and making them coefficients. Now the denominator is negative. Whenever it's in the denominator, you subtract. This is like in the first half of pre-cal. All right, minus ln of 3x plus 4. Why on earth would we do that? Well, I just made it 3 separate problems. Like, so I broke it into pieces. Okay, so it's not too much all at once. So we can just do the first part. What is that derivative going to be? Just this. Yeah, 2 over x, which I think is what you did. The derivative of ln is rational. That would be 1 over x. There just like so happens to be a 2. Same thing's going to happen with this one. It would be 1 over x minus 1. Like it would look like this. 1 over x minus 1. But there's a 1/2 there. So you would just like keep the half. There's also technically a chain rule there, but what's your derivative of x minus 1? 1. So like you can write times 1 if you want. Minus, right? And then this would be 1 over 3x plus 4. And then chain on the derivative of 3x plus 4, which would be what? 3. Those 3's don't cancel. Why not? Yeah, because that 4, this is like grouped together. All right, last one. Equation. We need a point and a slope. Let's see how messy this one gets. Forget. Yeah, it's not too bad. It just looks weird. All right, we're going to plug in e squared. So let's plug in e squared to get our point. E squared cubed. Let me write down what that would look like. E squared cubed. That would be e to the 6. Good. So it's going to be e to the 6. And then it's ln e squared. But what happens to ln and e? Since they're inverses, what do? Yeah, they cancel, so you just get 2. So actually, it's going to be 2e to the 6. So we just plugged e squared into this. Squared cubed was to the 6. ln and e cancel, you just get 2. So 2e to the 6. Where does slope come from? Derivative. So let's get the derivative. What rule do we need? Product rule. Good. First thing is x cubed. Derivative of the second. Derivative of ln. 1 over x. Perfect. Plus the second thing. And then times derivative of the first, 3x squared. Good. And we're going to plug in our point of tangency. So plug in e squared. Now, first of all, what's going to happen with this? Because one of those x's will cancel. So this will actually just be what? That'll just be x squared. Good. So if we plug in e squared squared, e to the fourth, plus, here, if we do ln e squared, it would look like that. So that would just be what? 2, good. And then if you plug in e squared here, again, e squared squared would be e to the fourth. So you'd have 3e to the fourth. Oh my goodness. So that's 1e to the fourth plus 6e to the fourth would be 7e to the fourth. I get that it looks crazy, but remember, e is a number. These are all just values, right? And then you're just going to write your answer. It looks crazy, but don't discriminate. Y minus what? Here's your point and here's your slope. So y minus 2e to the 6, beautiful, don't let it bother you, equals 7e to the fourth. I kind of like these. It looks crazy, but it just is awesome. Parenthesis, x minus, that's the answer.